Hi everyone, a very good morning to all of you. Sorry, good evening to all. Now we are going to study about gravitational field and potential. So what is the gravitational field, what is gravitational potential, and what is the relation between gravitational field and potential, and what kind of questions will come based on that. That is what we need to understand here. It's all about. So the very first thing here what we have to understand is what is gravitational field. So gravitational field at a point, at any point, nothing but gravitational force per unit mass. At any point, if there is a mass, then the gravitational field I equal to gravitational force experiences per unit mass. So that due to a point mass at any distance, there is a gravitational field that is gm by r square at any distance. As gravitational force is attractive in nature always, so the gravitational field always directs towards the mass. That is, the gravitational force and field both are vector quantities, and F bar and I bar both always lies along the same direction. Now, what is gravitational potential? So the gravitational potential means when you move a body from infinity to a particular point, let's take this point P, in the presence of external masses, there are so many other masses. We don't know how many are there, but let it be one or two or more. Now when you move a body from from infinity to a particular point, then you have to do some work. So the work done in bringing infinity to the given point at a distance r. Then if you consider only two particle system like m is at infinity. Now this is small m, this is capital M. Now you are moving from infinity to a separation r. Then the work done will become minus gmm by r. So this only called gravitational potential energy. And the negative sign represents that gravitational force is attractive in nature. Now, this work done per unit mass, whichever you are bringing, this we call it as V, that is gravitational potential. So that due to a point mass at any distance, the gravitational potential is, if there is a mass m at any distance r, the gravitational potential is minus gm by r. Now the next thing is what is the gravitational field and potential due to a point mass. Just before we have taken already, when there is a point mass m at any distance, the field magnitude is gm by r square and the potential is gm by r. But field is vector quantity, potential is scalar quantity. If you just take magnitude, then V equal to Gm by R equal to Gm by R square times R, nothing but I into R. So V equal to IR or I equal to V by R. This is the relation between field and potential due to a point mass. Also, there is a general relation between the gravitational field and potential. See here, the gravitational force is F bar equal to M into I bar. And the gravitational potential is work done per unit mass. Now work done means integration F dr per unit mass. Then force by mass is nothing but gravitational field. So integration, this is like F bar dot dr bar. So that I bar dot dr bar. So from this, we can write that I equal to minus dV by dr. So that is what relation between field and potential. See here, what is the relation between gravitational field and potential and how to find field from potential. See here, just before we said that the gravitational field is negative gradient of potential. That means if you take gravitational field as it is vector, there are components. Let's take I component and j component and k component. Now, how to find x and y is x is minus dou v by dou x and y is minus dou v by dou y and z is minus dou v by dou z. So here partial differentiation we have to do. That means when you want to find x quantity, x component of gravitational field, then you have to consider y and z as constants. For example, I will show you v equal to x square yz. Then the very first thing is Ix. Ix is minus dou v by dou x. With respect to x, yz is constant. So it will come out. So differentiation of x square as usual formula, same like differentiation. So minus 2xyz. Similarly, when you want to find Iy, minus dou v by dou y. With respect to y, x and z constant. So x square z. So that minus dou v minus dou y by dou y. So it will become minus x square z. Similarly, Iz if you calculate, you will get minus x square y. Then you can substitute Ix, Iy, that means minus 2xyz I cap minus x square z j cap minus x square y k cap. If they mention xyz coordinates, then you have to substitute and you have to find it. So this is one of the important kind of question. Similar kind of question also comes in electrostatics. Their electric field and electric potential. So how to find electric field from the conservative potential equation? So they may give in terms of xyz, they may give in xy, they may give in yz, they may give in terms of xz. Depends. But here you have to follow what? Partial differentiation. Partial differentiation, differentiation, same formulas. The only difference is here with respect to one variable, other variables remains constant. You have to treat them like just like constants. Now, what is gravitational field and potential due to continuous mass distribution? Now, due to continuous mass distribution means there are different bodies like a ring. So when you consider a ring at any point, let's take the radius r. Now at any point on its axis at a distance x, the gravitational field is gmx by r square plus x square whole power 3 by 2. Then gravitational potential will become minus gm by under root r square plus x square. So this is the gravitational field and potential due to the uniformly distributed ring, like a circular ring, circular coil. Now the next thing is, next object what you have to remember is, one is solid sphere. So when you consider a solid sphere of radius r, there are three kinds of points you will get. One is inside, one is on the surface, one is outside. So when you consider inside, the field is gmr by r cube and potential is minus gm by 2r cube into 3r square minus r square. Now on the surface means field is minus gm by r square and potential is minus gm by r. Now at any point outside when you consider, the field is gm by r square and v equal to minus gm by r. Here r is less than capital R. Here r is greater than capital R because it is outside point. Now similar way, when you consider shell. Now here also 3 points you will get inside, on the surface, outside. Now when you consider inside, the field is 0 because there is no mass and potential is constant and that is same as that of on the surface. Inside everywhere it is same as that on the surface. On the surface same formulas like solid sphere. So V equal to minus Gm by R. And outside when you consider I equal to again same formula Gm by R square. V equal to minus Gm by R. M is mass and R is radius. So these are the three objects. Usually they will ask based on which field and potential, because these are what? Continuous mass distribution. Mass is distributed over particular area or length or volume, then we call it as continuous mass distribution. Then let's see few examples based on whatever we have seen. Like, what is the gravitational field and potential due to a point charge? What is the relation between field and potential? And how to find electric field from the gravitational field from gravitational potential? And what is the field and potential due to continuous mass distribution? Now here is our first question, that is, a heavy point of mass 15 kg is placed at the origin of coordinate axis. Find the gravitational potential at a point located at x equal to 5 meter on x-axis. A heavy point of mass 15 kg is placed at the origin of coordinate axis. Find the gravitational potential at a point located. Very simple question. So this is x-axis, this is y-axis, this is origin. Now here one mass 15 kg is there. Now it is, you have to find at a distance 5 meter what is the gravitational potential. Direct formula Gm by R. So G is 6.67 into 10 power minus 11 into mass is 15 by 3. Sorry, this is 5. So 5 3s are. So you just multiply it. So 20.01 into 10 power minus 11. So minus 11. This is the gravitational potential. Now the next question. Two heavy point masses and separated by a distance. What will be the potential at midpoint of the line joining them? See, whenever they are asking the field and potential due to number of point masses, potential means you can add directly because it is a scalar quantity. But field, when they are asking, you have to apply the vector resultant formula, just like we have done in electrostatics. So two heavy point masses, let's take M1 and M2. Now they are separated at a distance R. What will be the potential at midpoint? Midpoint means the distance. Let's take this is x, means this is also x, where x is half of the total distance. Now the total potential means V1 plus V2. V1 is Gm1x and V2 also Gm2 by x. Now the total potential means V1 plus V2. So G by x, if you take common, M1 plus M2. So G by x is R by 2, M1 plus M2. So it will become 2G by R into M1 plus M2. All the values they have given. M1 is 10 power 3, M2 is 10 power 5, R is 200, G is constant, we knew it. So just substitute and try to get the answer. Now the next question is, the radius of Earth is, so radius of Earth is given 6.37 into 10 power 6 meter. And its mean density, so density of Earth is 5.5 into 10 power 3 kg per meter cube. And G value also they mentioned. Find the gravitational potential on the surface of Earth. So Earth means it is solid sphere. That is the first thing you will realize. So that you can apply the continuous mass distribution formula. So they are asking on the surface. So on the surface, the gravitational potential is Gm by R. All the values they have given. So G they have given, and mass also 6.37 into 10 power 6 by radius is, mass is, no, they have not given mass. They have given density. So there you have to do little manipulation, like G by R into mass means volume 4 by 3 pi r cube into density. Then it will become 4 by 3 pi G rho R square. Now you can substitute the values. So G by 3 into 4 pi into density. Mean density is 5.5 into 10 power 3 into radius is 6.37 into 10 power 6 whole square. So the calculation here becomes little bit tough, but you need to take approximation. Like here 2.2 approximately you take. Now here 4 into 5.5, it is like approximately 22. Then pi value also you try to take 3.14 means approximately 3. Here you decrease the value. So here you increase the value slightly. 6.37 you take approximately 6.4. So like that, when you take approximation and try to do the calculation, but make sure that options are not so closer. Most of the time they will not give close options so that you can apply the approximate values. But when the options are very close, then we don't have choice. We have to do all the full calculation fast. So that is what I used to say always. Calculation always takes important role. It's saving time. So that's why please practice such kind of calculation 2-3 times at least. Same calculation when you try to do it 2-3 times, then you will get then you can improve your perfection. Now the next question is, a particle of mass 1 kg is kept on the surface of a uniform thin spherical shell of mass 20 kg and radius 1 meter. Now the mass is 20 kg and radius is 1 meter. Now it is a thin uniform spherical shell. This is shell. Now they have given mass and they have given radius and one mass is kept on the surface. Now find the work to be done against the gravitational force between them to take the particle away from the thin shell. Away from the thin shell means to take it to infinity, because you have to take it away from it completely. Means you are taking it away means completely you have to go to infinity. Then the work done. See, when you are moving from infinity to this one, that is called potential. So work done is nothing but mass into potential difference. Now here work done, because potential difference equal to work per unit mass. So remember here one thing I would like to give the clarity. See, from infinity if you move to a point, that is potential. Work done per unit mass. When you move between 2 points, that is here potential V1, V2, then potential difference equal to work done per unit mass. But here when you consider one point as infinity, then that potential will become 0. So that work done equal to mass into final potential at infinity minus initial potential energy on the potential on the surface. So that this value will become 0, so that minus mvs. Now work done equal to minus m into potential on the surface. Who will produce potential here? The thin spherical shell, that is minus gm by r. So that work done will become gmm by r. So that is the work done in moving it from the surface to away from it. Now one more question. One last and final question. If gravitational field is given by, so they have given gravitational field minus xi cap minus 2y square j cap, where gravitational potential is, when gravitational potential is 0 at 0 comma 0, find potential at. So at 2 comma 1, what is the potential they are asking? Now delta v equal to minus integration e bar dot dr bar, where dr bar we will take it as dx I cap plus dy j cap. Now delta v means final minus initial. So v2 minus v1 equal to minus integration. You have to move from r1 to r2. That is e bar dot dr bar equal to ex dx plus ey dy. Because dot product means I coefficient into I coefficient. Like this is ex I cap, ey j cap. Then if you take that minus integration, here ex place what is there? Minus x dx. Now here the limits are from R1 to R2. Now 0 comma 0 to 2 comma 1. So that means here 0 to 2 and the other one is integration. Ey is minus 2y square dy. This is from 0 to 1. So you have to take the x coordinate separately and y coordinate separately. So that if you take minus common, minus minus will become plus. Integration x dx is x square by 2. But v1 is 0, so v2 final potential. X square by 2 from 0 to 2 minus this is y square means y cube by 3 from 0 to 1. So if you substitute the limits, how do we substitute the limits? Upper limit minus lower limit. So then you will get the final potential at the final point. As I said, sometime they will ask question based on electric field and potential relation. So here they are asking the potential from the field. You want to find potential from the field means go for integration. If you want to find the field from potential means as I have shown, you have to go for partial differentiation. So these are all the type of question they used to ask based on the gravitational field and potential. So just try to understand and remember each and every formula and the method how to find the relation between field and potential. So except the field and potential relation, remaining everything is based on formulas only. So similar questions I have given as an assignment. So please try to understand and try to solve it. So thank you. We'll continue in the next session with the next question. Thank you.